Hi, in this discussion, we're going to talk about a design pattern that we use many times in iOS 6 and Objective-C called target action. So let's get started with this. Target action is simply a design pattern that specifies an object, which we call the target, and a method of that object, which we call the action, to be run when something happens. In iOS, the most frequently used setting of target action is to specify an IB action method to be run on the view controller. And we've already seen this, where we drag a button to the view controller and then link it to an IB action method. In that scenario, the action is the IB action method that we link the object to, the control to, and the target is the view controller class in which the action method is declared and defined. And this is the usual way that we see target action in Objective-C when we program for iPhone with iOS 6. Now, in Xib and storyboard settings, you really don't see this happen because the code for the view and all that target action stuff is compiled from the XML that underlies the Xib file or the storyboard. However, it does happen. Target action is used to hook up active controls on the view to methods, actions, in the view controller, which is the target. Now, we can also create code to create a control on the view. In this case, we have to manually add the target, the action, and the control event that triggers the action. And Objective-C, using iOS, has a very helpful function that returns void called add target action for control events. And we're going to talk about each parameter in this list. If we create the control down in the view itself in code, in the UI view subclass that we create for that view, the target is going to be the view controller itself. But if we create the control in the view controller, and this is overwhelmingly the usual case, we create it in the view controller and point to the view, the target is going to be self because the method is defined in the view controller. The action parameter is a selector, and a selector is a special type. It's a typed definition of the method name. It's the method name as a variable of type cell. And this is the compiled method name. So to make a selector, we use this special syntax, @selector, and then in parentheses, the method name. Now, cell variables point to the compiled method. Methods of the same name, even in different classes, will have the same selector. And this is very important. This has to be this way because of polymorphism, which we talked about a little bit when we talked about Objective-C. If the method has no parameters, we omit the colon. Typically, when we're setting up target actions for things like buttons or UI controls that are active controls, we omit that colon unless we need to get to the selector. Now, when we set up a target action on a control, we have two optional parameters. The sender, the control that sent the event, and then the event itself, and we can use those as well. A typical call to this add target action with control events method, or for control events method, would look like this. If we have a UI button object named myButton created in a view controller that invokes the tap button method, it would look like this. We would use myButton as the receiver of the method and then call add target on self, because we're defining in the view controller, action @selector tap button. Notice this isn't an NS string. This is just the name of the method put in there. We're assuming tap button here has no parameters, and this is usual. And then for control events, and then this UI control event touch up inside. And this is our touch up inside event. We're going to talk about this in the next slide, the control event enum. The set target method is defined for all UI controls, actives, passives, everything. So it's defined in the class UI control, so all controls inherit this method. And we can set a target action for control event on any UI control subclass. The control event itself comes from an enum. The name of this control event is going to be UI control event plus the name of the event that we have in IB when we hook up that event in camel case. So for the touch up inside event for a button, it's UI control event touch up inside. It might be UI control event value changed for a segmented control, for instance, or UI control event did end on exit for a text field. So it's always UI control event and then the actual event crammed together without spaces in camel case. Now, in all fairness, with the ability that we have to create user interfaces in Interface Builder, we very rarely need to create controls in code, but when we do so, we can see the underlying target action mechanism that even exists when we create using a storyboard or a nib file, a zip file. So now, when we look at our target action 2 demo, our demo 2 in the demos, we're going to run into a concept called frames and bounds. So what this really means is where on a view a subview of that view is positioned. And a subview of that view would be a control or another view that contains controls or so forth. UI control itself is a subclass of UI view. So all controls are views. A button is a control. In turn, it is a view. So we have frame coordinates and we have bounds coordinates. A frame is actually a C struct. It's a CG rect struct. It's a rectangle that specifies 4 coordinates, the top and the left, and then the width and the height of the control. The context for this frame, this rectangle, for a control is within the control or the view that contains it. So a control's frame specifies the top left coordinate within its containing view and also its width and its height. Now, on the other hand, a bound for that control is defined as a rectangle with 0, 0 as the top left coordinate and width and height as the width and the height. Now, what this means is that a control's bounds are always 0 based. In other words, the top left corner of a control's bounds are within that control. Outside of that control, the positioning of that control within its containing control, we call that the frame. Now we refer or we use the frame of a control when we position it within another control. We use the bounds of a control when we position other controls within that control. So that's pretty simple. So let's look at a picture of this. We have a view, and we're saying that this view, this light blue view here, takes up the entire screen. Its frame, just arbitrarily, is 0, 0, 300, 200, meaning that the top left corner is at 0, 0, since it's taking up the entire screen, and it is 300 units wide, pixels or points, and 200 units high. Its bounds are also 0, 0, 300, 200, because we're looking at the internal coordinates of this view. So the frame is external, the bounds is internal. Now we have a control positioned 65 units from the top and 55 units from the left of this view, and it is positioned within the view. It is 50 units tall and 80 units wide. So this control's frame is 55, 65, 80, 50, because the frame is the coordinate system within its containing container, or that's silly, within its containing view. So the view's frame is 0, 0, 300, 200. The control's frame is 55, 65. In other words, it's 55 points to the left in the view and 65 points from the top into view, and then its width is 80 and its height is 50. This control's bounds, though, are 0, 0, 80, 50, because now we're looking at the internal coordinates of the control. If we added a new control inside this control, let's say, if this control is a view, we could add a new control inside this view, and let's say it's at 30, 40, someplace down here. And what would happen there is that control's frame would be 30, 40, and then its width and its height, but its bounds would be 0, 0, and its width and its height. Okay, so look at the two demos that we have showing target action in action, and look at, in the second demo especially, how we create the frame and the bound for the button that we add to the view as a subview, and then how we handle, of course, target action on that button. Thank you very much.